Fun with magnets. Learning about magnets. Discovery of magnet. It is said that more than 2500 years ago, there was a shepherd named Magnus who lived in ancient Greece. He used to take his herd of sheep and goats to the nearby mountains for grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached at one end. One day, he was surprised to find that he had to pull hard to free his stick from a rock on the mountainside. It seemed as if the stick was being attracted by the rock. The rock was a natural magnet and it attracted the iron tip of the shepherd's stick. It is said that this is how natural magnets were discovered. Such rocks were given the name magnetite, perhaps after the name of that shepherd. Magnetite contains iron. Some people believe that magnetite was first discovered at a place called Magnesia. The Greeks later called this rock magnetite. Its chemical name is iron oxide, Fe3O4. The name magnet is derived from the magnetite and it represents all materials which attract iron. Pieces of magnetite were found to point in the same direction, north-south, when freely suspended or pivoted. So, they were also called leading stones or lodestones. The Chinese are believed to be the first to use them as direction indicators. The phenomenon of attracting iron and pointing in the north-south direction is called magnetism. Artificial magnets are made by humans. They are made in different shapes, for example, bar magnet, horseshoe magnet, cylindrical or a ball-ended magnet, Robson's magnet, and magnetic needle. Magnetic and non-magnetic materials. Magnetic materials are attracted by a magnet and can be converted into magnets. Iron, cobalt, nickel, and mixtures known as alloys of these metals with other metals are examples of magnetic materials. Iron shows strong magnetic properties. All materials other than magnetic materials mentioned are not attracted by magnets. These are in general called non-magnetic materials and they cannot be made into magnets. Properties of magnet. Poles of a magnet. Magnet can attract iron, cobalt, nickel, and alloys containing these metals. The pull exerted by the magnet on these materials is called magnetic force. Activity. Spread some iron filings on a sheet of paper. Now place a bar magnet on this sheet. Some parts, especially the two ends, attract more iron filling than the other parts. So these parts have more magnetic force than the other parts. These strong parts are called the poles of the magnet. The magnet has two poles. Finding directions. Activity. Suspend a bar magnet by a thin thread from a wooden stand. Gently tap the magnet so that it swings freely. Note the position of the north-south direction of the magnet when it comes to a rest. The compass is kept at the place where we wish to know the directions. Its needle indicates the north-south direction when it comes to rest. The compass is then rotated until the north and south marked on the dial are at the two ends of the needle. To identify the north pole of the magnetic needle, it is usually painted in a different color. Make your own magnet. Take a rectangular piece of iron. Now take a bar magnet and place one of its poles near one edge of the bar of iron. Without lifting the bar magnet, move it along the length of the iron bar till you reach the other end. Repeat this process about 30 to 40 times. Bring a pin or some iron filings near the iron bar to check whether it has become a magnet. If not, continue the process for some more time. Remember that the pole of the magnets and the direction of its movement should not change. Attraction and repulsion between the magnets. Let us play another interesting game with magnets. Take two small toy cars and label them A and B. Place a bar magnet on top of each car along its length and fix them with rubber bands. Now, we will note the observations by placing the two cars in different positions. Front of car A. Direction of magnet, south. Facing the front of car B. Direction of magnet, north. The cars will move towards each other and collide. Rear of car A. Direction of magnet, north. Faces the front of car B. Direction of magnet, north. The cars will not move at all. Car A. Direction of the magnet, south. Placed behind car B. Direction of the magnet, south. The cars will not move at all. Rear of car B. Direction of the magnet, south. Facing rear of car A. Direction of the magnet, north. The cars will move towards each other and collide. From this activity, we conclude that like poles of the two magnets repel each other and unlike poles attract each other. Demagnetization of magnets. A magnet can be demagnetized, that is made to lose its magnetism by heating the magnet, hammering, dropping. Uses of magnets. Magnets are used for several purposes and in many devices. Magnets are used in electricity meters, refrigerator doors, dynamos of bicycles and automobiles. Magnetic tapes, plastic tape coated with magnetic material, are used as audio and video tapes. Nuclear magnetic resonance, NMR, images is used to study the brain. Magnets are used in toys as well. Summary. Magnetite is natural magnet. Magnet attracts materials like iron, nickel, cobalt. These are called magnetic materials. Materials that are not attracted towards the magnet are called non-magnetic. Each magnet has two magnetic poles, north and south. A freely suspended magnet always aligns in north-south direction. Opposite poles of two magnets attract each other, whereas similar poles repel one another. That is all in this lesson, students. Enjoy with magnet by playing safe games.